Welcome, my dear student, in our math program for secondary 3. Dear student, today we are taking new lesson in static. What is the title? Its title is an equilibrium. Equilibrium of a rough plane. Dear student, look at introduction of an equilibrium. Dear student, at the first, we are taking properties of static friction force. We know that we have two types of the friction force: static friction force and kinetic friction force. What is the properties of the static friction force? Look at number 1. The static friction force, F, acts in opposite in the slide. It is the opposite direction to direction which the body tends to slide. Number 2, static friction force, F, is only equal to tangential force which tends to move the body so that it can be more than such a force. Number 3, the static friction force, F, increases whenever the tangential force which causes the motion increases. It is always equal. It is equal to in n magnitude as long as the body is in a state of equilibrium. Number 4, static friction force increases up to a certain limit, which it doesn't exceed it at a such limit. Remember, very important property, the static friction force increases up to a certain limit, which it doesn't exceed it at such a limit. The body is about to slide in this case. The body is about to slide or about to move in this case. The friction is called limiting static friction force. Is denoted by Fs. What you mean Fs, dear student? Dear, Fs means static friction force when is limit of the friction is called limiting static friction. It's denoted by Fs. Number 5, ratio between limiting friction and the normal reaction N is constant. Ratio between limiting friction force and the normal reaction force N is constant. It is symbol μs. What is the meaning of μs? Yes, friction coefficient force. Coefficient of friction force equals Fs over N. What is the Fs? Static friction force. What is the N? Normal reaction. Remember, dear student, what is the meaning of coefficient of friction force or static friction force? Ratio between static friction force and normal reaction. Dear student, note that coefficient of friction, static friction force must be more than 0, smaller than 1, where μs is static friction coefficient. Sometimes, dear student, μs may be more than 1. Remember, dear student, μs sometimes may be more than 1. Now we are translate to kinetic friction force. What you mean of kinetic friction force? When the body is about to move, then the force which tends to the body is moved is called kinetic friction force. The ratio between kinetic friction force and normal reaction is coefficient of kinetic friction force. Its symbol mu k. Mu k equals Fk over N. Dear student, resultant R dash equals square root n square plus f square. Dear student, n square, what is the n? Normal reaction. What is the f? F in static is called static friction force. In kinetic is called kinetic friction force. R dash equals square root n square plus f square. R dash is resultant of the normal reaction n and friction force. When the friction force is limited, we have R dash equals, yes, n square plus fs square. What is fs square? Fs means static friction force. When f is about or is limit, then f is called fs. R dash resultant reaction equals normal reaction square or normal reaction for all power 2 plus static friction force for all power 2 under square root. Then R dash equals square root n square plus fs square. Since fs equals mu s times n. Why? Because we have coefficient mu s equals fs over n. Therefore, fs equals mu s times n. By substitution about fs equal mu s times n under square root, then R dash becomes square root n square plus n square mu s square. By taking n square highest common factor, then R dash becomes n multiply square root 1 plus mu s square. Remember, dear student, in this case, resultant reaction force R dash equal normal reaction multiply square root 1 plus mu s square. What is the mu s square? Mu s, remember, equal fs over n. Coefficient friction force equals static friction force over normal reaction n. This equation is very important. When we find R dash of or resultant of reaction force, we have n or normal reaction force and mu s. By substitution about n multiply square root contains 1 plus mu s square, we find R dash or resultant of R dash. Dear student, look at the remark. We have body act on the plane. We have BS force and this body its weight W. Its normal reaction N R dash is resultant of N and Fs. Look at tan lambda. Tan lambda equal Fs over N. Why? Because look at Fs is horizontal force. N is reaction force. Tan opposite over adjacent equal Fs over N. By this rule, we have Fs over N equal mu s. In this case, tan lambda equal mu s. Why? Because the first equation, tan lambda equals Fs over N, and mu s is coefficient friction, static friction force coefficient equal Fs over N. Therefore, we deduce that tan lambda equals mu s. Dear student, look at the opposite figure. The opposite figure, the body become in an equilibrium under action of two forces. Number 1, the weight of the body W that acts vertically downwards and its magnitude W. Number 2, resultant reaction and its magnitude R dash. Look at the body, its weight W, resultant reaction R dash. From equilibrium condition, we have R dash equals W. This is number 1. Number 2, F equals W sine theta. The two equations of an equilibrium. In this case, look at N equals W cosine theta. Look at, dear student, the plane inclined the horizontal by angle theta. We resolve W in slope of plane W sine theta and W cosine theta in two perpendicular axes. Then N equals W cosine theta. Look at the important example. Body of weight 3 newtons is placed on a plane inclined by angle of measure 30 degrees and the static coefficient friction between the body and the plane 2/3. A force of magnitude 2 Newton act on the body and in direction of the line of the greatest slope upwards. If the body is in equilibrium, determine the friction state whether or not the motion is about to begin. Look at the solution. Dear student, the body is weight 3. There are forces N, forces 2 act the body. Look at the figure. We obtain equation of an equilibrium. Remark, the body or the plane inclined the horizontal by angle 30. Weight of the body 3 Newton. 3 Newton. We resolve in 3 cosine 30 and 3 sine 30. Since B equal F plus W sine 30. What is the B? 2. 2 equals F plus 3 times sine theta sine 30 equals half. After that, we find the value of F. Therefore, F equals half Newton. By substitution, since N equals W cosine theta, therefore, W3 cosine theta cosine 30. By substitution, then N equal 3 cosine 30 equal 3 over 2 root 3 Newton. What you notice, dear student? Fs equals mu s times N. By substitution, equals 2/3 times 3 over 2 root 3. Mu s equal 2/3. What is the value of N? 3 over 2 root 3. Answer is root 3 Newton. Then Fs equals root 3 Newton. What you notice? F smaller than Fs or Fs more than F, then the friction is not limited. Why? Because Fs more than F. Therefore, the body is not about to move. Why? When Fs more than F, then the body in this case is not about to move. Another example. Body of weight 10 kilogram weight. is placed on a rough, inclined plane. Force B act on it in direction of the line of the greatest slope up. If it's unknown that the body is about to move upward the plane when B or the force equals 6 kilogram weight. Remember, the body is about to move upwards, then the plane when B or the force is 6 kilogram weight, and a body to move downwards when B equal 4 kilogram weight. Find the angle of inclination of the plane to the horizontal. Number B, the static friction coefficient, or mu s. Look at the solution. When B equals 6 kilogram, we know that the body is about to move up the plane and the static friction is limiting and acts down the plane. Why? Because, dear student, the body move up. When the body move up, then the static friction is limited. Fs in this case smaller than F and act down the plane. Look at, dear student, the body it's weight 10 Newton. We resolve 10 in 10 cosine theta and 10 sine 30. Look at the force 6 and normal reaction N1. The body move to upward. In this case, the friction force is downward, opposite direction. Mu s equals mu s to N1. Fs in this case, dear student, equals ms N1. By using equation of N equilibrium, N1 equals 10 cosine 30 and 6 equals 10 sine 30 plus ms N1. By substitution from 1 and 2, or from the two equations, we find 10 sine theta plus 10 mu s cosine theta equal 6. This is number 1. When B or the force equal 4 kilogram weight, the body is about to move downward the plane. Then in this case, the static friction is limited and acts up the plane. Dear student, the static friction force is opposite direction to the force B equals 4. Look at the figure. We have 10 weight of the body, but the force is 4, becomes 4 instead of 6. And in this case, dear student, the body is moved down. The static friction force is up, mu s N2. We have two equations. The first equation N2 equals 10 cosine theta, and the second equation 4 plus mu sn equal 10 sine theta. By using two equations, we obtain second equation 10 mu s cosine theta equal 10 sine theta minus 4. From two equations 1 and 2, we deduce that 6 10 sine theta plus 10 sine theta minus 4. Therefore, 10 sine theta equals 20 sine theta equals 10. Therefore, sine theta equals 1 over 2. What is the value, or what is the angle or inclination angle of the plane by horizontal? Theta equal 30 degrees. Dear student, this example is very important. We have two forces. The first force is 6 kilogram weight. This force makes the body moves upward. Then the static friction force is opposite direction in downward. The second force is 4. 4 makes the body moves downward. Then the static friction force is upward. We obtain two equations from 6 force and 4 force. After that, we find angle of inclination of the plane and horizontal. Sin theta equals 30, then theta equals 30 degrees. This is important example. Dear student, look at another example. After we have theta equals 30, by substitution in equation 2, we find mu s, coefficient of friction force, 1 over 5 root 3, multiply root 3 up and down, then coefficient friction force equal root 3 over 15. This is static friction between about plane coefficient. Now we are translate to another example. Body of weight 2 kilogram weight is placed on horizontal rough plane. Then the plane is inclined step by step so that the body become about to move downwards the plane when the measure of angle of inclination is 30 degrees. Find the static coefficient friction mu s between the body and the plane. And if the body is tied by a string and the string is tension in a direction makes an angle of measure, and the body is tied by the string and string is tension of direction makes angle of measure 60 degrees to horizontal until the body become about to move upward the plane. Find the magnitude of the tension force. Number B, magnitude of static friction force. The required, dear student, the magnitude of tension force. Number B, magnitude of static friction force. Look at the solution. Look at, dear student, body its weight 2 kilogram weight. We resolve 2 into cosine 30 and 2 sine 30. The body makes angle 30 with horizontal or the plane inclination angle with the horizontal 30 degrees. Theta equals 30. We have tension T. We resolve T in T cosine 30 and perpendicular direction to sine 30. Look at the body is moved upward, then mu Sn is downward. What do you mean mu Sn? Excellent student. Mu Sn means static friction force or limit friction. Limit friction means static friction force. Mu Sn is downward. Why? Because the tension makes the body move to upward. We obtain the equation of an equilibrium. The body is about to move downward under action of its weight only. Then mu s equal T sine 30 equals 1 over root 3. But equation of equilibrium are n plus T sine 30 equal 2 cosine 30, n equal root 3 negative 1 over 2 t. Then T cosine 30 equal 2 sine 30 plus 1 third n. Therefore, 3t equal 2 root 3 plus 2n. This case from 1 and 2, 3t equal 2 root 3 plus 2 multiply root 3 minus 1 over 2t. This equation is t is unknown. By substitution, 4t equal 4 root 3, therefore t equal root 3 kilogram weight. The tension force is root 3 kilogram weight. This is equation number 1. In equation number 1, by substitution about t equals root 3. Therefore, n equal root 3 minus 1 over 2 root 3 equals what? Root 3 over 2 kilogram weight. The static friction force, mu Sn. What is the value of mu S? 1 over root 3. What is the value of n? Root 3 over 2 equals 1 over 2 or equal half kilogram weight. Mu Sn equal 1 over 2 kilogram weight. When we find, dear student, mu Sn, what you mean mu Sn? Mu Sn means static friction force. Find the value of mu S and find the value of normal reaction. Look at, dear student, when look at the graph or the opposite figure, we have tension T. Tension T or tension force T, we solve it in the slope of greatest plane T cosine 30 and in normal n. And remark, when the body moves upward, then static friction force, its opposite direction downward. In the figure, what is the static friction force? Mu Sn or Fs. Fs is limiting friction force. Limiting friction force, mu Sn. We have two equations. N plus T sine 30 equals 2 cosine 30. What you mean? Sine 30 half. We find the value of N and value of T by substitution about two equations. What is the second equation? 2 cosine T cosine 30 equal 2 sine 30 plus mu Sn. After that, we find mu Sn. From the previous, we find mu S equal 1 over root 3 Newton kilogram weight. After that, we find n root 3 over 2. By substitution, mu Sn or static friction force equals 1 over 2. Dear student, what you deduce? Mu Sn equals 1 over 2. 1 over 2, this static friction force is more than or smaller than? Smaller than, because the body is moving upward. The body when move upward, static friction force is smaller than F. Then T cosine 30 more than mu Sn. Then the body is move upward. At the limit, dear student, or at the final, we deduce that when Fs more than F, the study is not move, doesn't about to move. But when Fs smaller than F, then the body is about to move. The condition of body move, yes, Fs is smaller than F. In this case is kinetic friction force. Then when we find static friction force, we find the value of Ms and the value of N. By multiply Ms times N, mu S is 1 over root 3. N normal reaction force equals root 3 over 2. After that, we find product of 1 over root 3 times root 3 over 2 equals 1 over 2 kilogram weight. Dear student, by end of the lesson, I am very happy to spend such time with you. Goodbye.